I'm very excited to hear about silver linings in every cloud, especially after working with lots of bare metal in the last few months. Please welcome Diana Yuryeva. How are you doing today?
I'm doing good, thank you.
Great.
All right, well, thanks a lot for joining me today. And in the next 15 minutes, I will compare and contrast what it takes to manage large IT infrastructure in public versus private cloud. This talk was actually inspired by my personal experiences. I've spent 5 years at Medallia, which operates 10 data centers across the globe. And then since November of last year, I've been working at Confluent, which does not own a single server and fully relies on public cloud. In both companies, I've held leadership roles in SRE organizations that managed large infrastructure supporting a SaaS offering. Given that I started my journey in private cloud, I was overly optimistic about being an SRE in the public cloud. And that's because my impressions of the public cloud were based on S3, that is simple, infinitely scalable, and highly available. You don't need to monitor it or plan your capacity. There are still some decisions to make, maybe about backups or security, but you'll make those decisions at design time. And if you made good decisions, you will not need to support day-to-day operations. It's truly an amazing product, which can make an entire team redundant. However, if you're running large infrastructure, you likely won't be using just S3. And as it turned out, most services in public cloud are not like S3. S3 is more of an exception to the rule. So what do the Netflixes, Slacks, or Capital Ones of the world actually use for their business when they say they adopted public cloud? Well, turns out their core offerings are complex enough. It's likely that when they say that, they actually use infrastructure as a service. And IS means dealing with low-level constructs, containers, VMs, volumes, and networking. So given that this talk is about tech companies with a big IT footprint, those companies would either be running private cloud, the stack on the left, or public cloud, which is IS. In both worlds, there's plenty of work to keep an SRE team busy. So spoiler, I'm not going to advocate for a particular model. Rather, my intention today is to share my personal take on differences and commonalities between these two operating models. Well, one big difference, which is hopefully evident from this diagram, is that if you're doing on-site, you will manage compute and networking equipment, as well as racks, cables, and power supplies. And you will need to buy all of this equipment, which means you'll be best friends with your procurement team and you'll work with vendors. You'll have to think about warranties, defects, decommissioning old hardware, and you will be doing things like hardware qualifications to find the right hardware spec for your needs and budget. And where does all this equipment go? Well, hopefully it's not in your garage. For a real company, it will be in a data center. Companies that own their data centers not only take care of the location, but need to think about power, cooling, network access. Alternatively, you can rent a data center from a company like Equinix in a co-location model where they take care of some of that shared concern and you just need to fill your cage with the hardware. You'll also need to hire special people to service this data center. These are called data center technicians. They're actually quite different from the rest of your SRE team, not just because they specialize in hardware, but this is one job description, which actually is physically demanding. They need to lift things, and they cannot be remote due to the nature of the world, of the job. So they will need to be present in that data center. What does all of this mean for scalability? As you can probably see, scaling is tricky when you deal with hardware. To expand an existing data center, you'll need new servers. And remember that your cage space is not unlimited either. And if you're adding a new data center, that is a huge deal. You'll need a new property, new contract. You'll need to work with vendors to ship hardware to the data center at the other end of the world, and you'll need to hire people to service this data center. And if you're serious about disaster recovery, to survive a loss of your data center, you actually need to have another one with idle capacity. On public cloud, you can launch in a new region with a click of a button. And to dynamically adapt to changes in demand, you can use autoscaling. However, there are limits to what you can achieve with it because of quotas and API limits. So when you actually create an ASG for your EKS, at some point you'll run into IP limitations. So you might need to create a new network. And then at some further point, you will run into limits of your account. So you'll need to create a new account. And there is no out-of-the-box solution for this kind of problems that you will inevitably run into with a large footprint. And this is something that your SRE team will be developing. When it comes to capacity management, you will be spending a lot of time doing forecasting in private cloud. It can take 6 months from the time you order a server to the time it arrives in your data center. This means that you will be doing projections a year or more into the future. And you'll need to plan for contingencies, such as supply chain shortages. And then, if you remember disaster recovery from the previous slide, well, you might actually need to buy twice what you need. On public cloud, even if you figured out your way around scalability issues discussed on the previous slide, don't assume that you can increase your capacity 10 times overnight. The underlying capacity is also limited, and a really large company can actually push the boundaries of an exotic region. So this is another thing you will be working with your account manager, with a cloud provider, if you're planning to really increase your capacity in a specific region. Your cloud provider should be able to handle reasonable requests with on-demand instances, but then there is another caveat. Those are not guaranteed. And as it turns out, companies with SLAs are not comfortable with taking that risk. So they still need a fair amount of redundant capacity. And that's why there is on-demand capacity reservations. You have to pay for them, and that takes you back to the planning board. You can also use reserved instances, and that will save you money. Reserved instances require a 1 to 3 year commitment. So in fact, you might be forecasting a lot more if you're using the public cloud and you're careful about costs. Speaking of costs, your cash flows would be quite different between the two models. Public cloud is more about pay as you use with some upfront payments, whereas in private cloud, you'll be making those big orders with lump sum payments, which may or may not be broken into installments. In both cases, strategic partnership with vendors are very important to negotiate discounts. And in both cases, you want to keep an eye on who's using the resources to avoid running out of capacity or getting a huge bill. Except you will likely need to build your own way to track this whenever you operate a data center. On the positive side, though, once it's purchased, short spurts are less painful. So if there is a leaking resource, given that you already have all that spare capacity in your data center, if you catch it early, there will be no financial consequences for you. Whereas on public cloud, you might end up with some bill shock. One other interesting difference is that public cloud offers fantastic features such as logging, monitoring, secret management, and you won't have to spend in-house development cycles to build them, but you'll also always incur the costs of using them. For example, Microsoft Azure charges its customers for point-in-time recovery of the database, and that's on top of the charges for instances and their backups. If you had to build this functionality with your own team, well, obviously it won't be available immediately and you'll spend engineering time to develop this. But after that, you can do point-in-time recovery all you want and it won't cost you any extra money. Well, let's talk about security and networking, and being diligent about security is always a good idea. But security is a bigger issue on public clouds because their APIs and offerings are available through public endpoints. Accidentally leaked access keys can be used to spin up virtual machines used for Bitcoin mining. And every now and then we hear news about exposed S3 buckets. So private clouds tend to run on networks that are not exposed to the internet, and any such access would be a result of quite intentional access. You likely won't create an S3 bucket and expose it to the entire world on a private cloud, because you'll need to work with maybe your networking team to create a DNS address. You won't do it by accident. On the positive side, though, when you're working with public clouds, the providers are really good at detecting this kind of intrusion. They will email you if they detect it. And sometimes I've even seen records of them refunding the money which was lost due to Bitcoin mining. Whereas if you're doing it all in your own data center, you'll have to develop all of that advanced detection infrastructure by yourself. But bottom line, I think everybody should be really serious about security, and you will be working on your security solutions in either cases. Networking tends to be also a little simpler if you're using private cloud. People tend to get away with simpler networking and security setups, whereas on public clouds, you will be dealing with advanced VPCs, roles, and things like that. All right, this is actually the last slide, and the last point I wanted to make is about feature development. And great advantage of the public cloud is that new features will be available to you, well, for free, with no investment on your side. For example, if you use Kubernetes, the provider will upgrade Kubernetes for you, so your team doesn't need to learn about new versions of Kubernetes. But the downside is that you have a lot less agency about it. For example, at the time of this talk, on Microsoft Azure, it is not possible to rotate a Kubernetes certificate without a downtime, but you can do it if you were just running Kubernetes yourself. And this is an example of a feature request where you would be working very closely with your technical account manager and pushing the cloud provider to implement this feature. But like I said, you don't have agency. So if it's not there, you have to wait and work with their timelines. Another thing to be frank about is that there will be bugs. And in my experience, while provider-wide outages are not common, you may still run into one-off issues, and you will need to talk to support, which can take a fair amount of time. Again, if you're used to fixing issues yourself, you may be feeling somewhat anxious. You feel, oh, I wish I had access to that VM because I would be able to fix it faster instead of waiting for the representative to get to me. And finally, not all interactions can be done through APIs, and some actions have to be done via UIs, which is not scalable. And we SREs, we don't like that because we like to automate things. For example, on Google Cloud, those quota increases you need for scalability, they have to be done via Cloud Console, and some even require an email exchange. So if you think you can set up a fully automated system which scales up, right now, this feature is not available, and it's another feature request that you would be dealing with. All right, well, that was fast, and hopefully everyone learned something new from this talk. If you want to learn more, there is no better way to learn about something than to work on it. We are hiring site reliability engineers, infrastructure engineers in USA, Canada, and Europe. So I've provided a link to the Confluent Careers website, and you're also welcome to check us out on Twitter, where our handle is Confluent Inc.
Great. Thank you, Diana. That was a nice lightning talk. We did get a question, I believe. Domi?
Yes, we have one question that came in from Ricardo. He wanted to know the following. There's an in-between scenario, which is rented bare metal. He's curious to know if you have any experience with it and what your thoughts are on it.
Meaning rented bare metal. I'm guessing that you don't own the bare metal and rather you are taking it from somewhere. Mm-hmm. I haven't been familiar with it personally. I'm guessing that takes out some of the pain through warranties, because like with a car leasing, maybe if that bare metal doesn't satisfy your needs, and has some issues, they will probably take care of that for free, but you will still be doing all the virtualization on top of that. And you probably need to choose what bare metal you need. And there are a lot of choices, how many networking ports you need, what is the right SSD configuration for you. So you probably will be choosing, making a lot of hardware qualifications with that.
I believe thank you for that. I think Ricardo just posted another example as in Equinix Metal.
I am not familiar with Equinix Metal.
That's fair enough. I don't know if we had any other questions. But apart from that, I really liked it. Like, it was very short and sweet, but it's very clear and concise. So thank you for that.
Awesome. Thank you.